We're going to look at Chapter 1, Section 1 of the Linear Equations, Inequalities, and Applications section of your textbook. In this section, we're going to distinguish between an expression and an equation. We're going to identify linear equations. We're going to solve those equations using the different properties. We're also going to look at ones that involve fractions or decimals and conditional equations as well. So to distinguish between an expression and equation, there are some key differences that we can use to do this. Recall that an equation is when two algebraic expressions are equal to one another. This means that there's always going to be an equal sign in an equation where an expression is not going to have an equal sign. So looking at these two examples, A has an equal sign, so it's going to be an equation. B does not have an equal sign, so it's going to be an expression. So let's identify linear equations. A linear equation in one variable has only real numbers, one variable raised to the first power. Now remember, we don't always show the first power. We don't write a 1 above it, but there should be no exponent written above the x value unless it's 1. A linear equation in one variable can be written as ax plus b equals c when it is fully simplified. It could also be something like 2x plus 5x plus 7 equals some value. The key here is that we have one variable in the expression and it is raised to an exponent of 1, meaning we don't really write an exponent, where a, b, and c are going to be real numbers. If a variable in an equation can be replaced by a real number that makes the statement true, we call that a solution. For example, 8 is a solution of this equation. If I do 8 minus 3, I get 5 on the left equals 5. 5 does in fact equal 5. So when we say true, that's what we mean, is that it truly does, the left and the right are truly equal statements. So an equation that is solved by finding its solution set is a set of all solutions. In an equation, a linear equation, there is one solution. So the solution set is only going to have one value in it. Equivalent equations, are related equations that have the same solution set. So I could have something like another equation where the solution is also 8. So I could have something like x plus 3 equals 8, where x is going to be 5. So I could have a different answer there. They're not an equation solution set because 8 is not a solution. But I could sit there and make some additional equations where 8 is going to be a solution, such as something like 2x equals 16. There, x is going to be 8 when we solve, so it has the same solution set as this equation, so they're going to be equivalent equations. Solve the linear equations using addition and multiplication properties of equality. So this means we're going to be solving them by doing these things instead of addition or subtraction. So if I have a, b, and c, and I have an expression where they are equivalent, that means I'm adding something to both sides of the equation to keep it balanced. The multiplication property means that I am multiplying something by both sides of the equation and that it is remaining balanced. So here is an example. 4x plus 8x equals negative 9 plus 17x minus 1. The first step is to combine my like terms over here on the left-hand side. 4 plus 8 is 12. That's where the 12x comes from. Over here on the right, I have negative 9 minus 1, which gives me negative 10. So I combine those two values. Next, I have to move the 17x to the left-hand side of the equation because we always want our variables on one side. The opposite of adding 17x is subtracting 17x. So I have to do it to both sides to keep my equation balanced. 12 minus 17 is negative 5. And then we're still left with a negative 10 over here to the right. Now, when I have negative 5 written next to x, that actually means negative 5 times x. We don't use a multiplication symbol because it would be confusing since most of the time multiplication is shown with an x. So if I had 5xx, that wouldn't make sense. So the opposite of multiplication is division. So I'm going to divide both sides by negative 5. Negative 10 divided by negative 5 is positive 2, and we've now solved this linear equation. I can then check my answer by taking that value for x and plugging it in to see if I get a solution that is true. So I'm going to simplify that using the order of operations, and I get 24 equals 24, which is a true statement indicating that this is a solution for the multiple choice question. Now, if I want to get a series of steps for this, a lot of times you want to have a series of steps. I would simplify the left and the right-hand side separately first. What does that mean? That means go ahead and combine any like terms, use the distributive property, clear parentheses, clear any fractions or decimals. All of those things need to happen on the left and right before I can solve. Then, once I've done all of those simplifications, I would worry about step 2, which is isolating the variable terms on one side. Then 3 would be to isolate the variable itself. So when I'm isolating on one side, that means I want to have all of my variables on one specific side of the equation. Once I get that, I want to have just x, just y, just some form of that. Then you want to check your answer. And this is a step that students often skip, but in the lab, it's really important, especially in your test, to check your answer because it's very simple to make a mistake with a negative sign, no matter what level you're in mathematics. So especially on the test, I strongly encourage you to go ahead and substitute the answer back into the equation to check and see if your solution is right. So let's look at the distributive property. If I distribute a sheet of paper to everyone in a classroom, that means that I hand it out to every single student. I don't skip any students. In math, we do distribution in the same way. Everyone inside the parentheses gets to get the sheet of paper. In this example, it's a 3 is my sheet of paper. Now, to do the operation for the distributive property, we would multiply everybody in the parentheses times 3. So I would have 3 times 4 and 3 times x. That's the distribution idea. 3 times 4 is 12. 3 times x is 3x. Now I'm going to follow those steps that we have, and I'm going to combine my like terms on the left and combine my like terms on the right. 3 minus x is 2x. Now I want to begin to isolate the variables on one side of the equation. So I'm going to subtract 2x from both sides. You could bring the 5x over to the left, but it would result in a negative number. It's okay, you could do it that way as well. This gives me 12 equals 3x minus 3. I then need to get that minus 3 or negative 3 over on the left-hand side so that my variables are only on one side. I do this by adding it to both sides because adding is the opposite of subtraction. This leaves me with 15 equals 3x. Remember, this is 3 times x, so the opposite of multiplication is division. So I'm going to divide both sides by 3 to get my solution of x equals 5. Then I'm going to check my answer by plugging 5 in everywhere I see an x and ensuring that I get a true statement. Here is another example. Notice there is not a number in front of the parentheses on the left-hand side. When we don't have a number shown, it's implied to be 1. So I need to distribute negative 1, because the subtraction symbol is there, it's considered a negative 1, to the 4 and the x. On the right-hand side, I need to distribute a negative 2 to the 3 and the 5. So when I do that, negative 1 times 4 is negative 4, so it's minus. Negative 1 times positive x is negative x. Negative 2 times positive 3x would be negative 6x. Negative 2 times positive 5 would be negative 10. Then I'm going to combine my like terms on the left and the right-hand side, and then I want to begin to isolate the variable. Adding x to both sides moves the x to the right-hand side and prevents us from having negatives there. You could move the 2x to the left-hand side. That's perfectly acceptable as well. Now I want to begin to isolate the variable, so I'm going to add 10 to both sides to get rid of that minus 10. Now I have 12 equals 3x, So I will divide both sides by 3 to get x equals 4. Linear equations that have fractions or decimals aren't as difficult as they first seem. When fractions appear as a coefficient, we multiply each side by the least common denominator of all the fractions. This is an application of the multiplication property of equality. So if I'm looking here, I have the numbers 2, 4, and 2. I need to find the least common denominator for 2, 4, and 2. You can do this by looking at multiples. The least common multiple of 2 and 4 is 4. So I would multiply everybody times 4. Now remember, this is a distribution. So when I do that, the 2 is going to cancel with 4, and this becomes a 1, and 2 goes into 4 twice, which is where this 2 comes from. 4 goes into 4 once, which is why there's not a number written here. 2 goes into 4 twice, so this 2 at the bottom cancels, and this 4 becomes a 2. 2 times 1 is 2. Then I'm going to distribute the 2 to the x and the plus 1 by multiplication. I'm going to combine my like terms, and then I'm going to subtract 5 from both sides to get that 3x alone. Now I'm going to divide both sides by 3 to get x equals -1. I can check my solution by plugging in -1 to ensure that I am getting a true answer, and I do. Now, if I have decimals, I want to clear the parentheses first. So the first step that I'm going to do is multiply 0.02 by 60, which gives me 1.2. Then I'm going to multiply the 0.03 by 50 and x, and so that now I have no parentheses left. Now, to get rid of the decimal, because each decimal here has a value in the hundredths place, we're going to multiply everybody in the equation by 100, which is going to give me 120 plus 4x equals 150 plus 3x. So I took 1.2 times 100, that got me 120. I took 0.04 times 100, and that is 4. So it's a simple calculation of multiplying by 100. If there was a value like 0.003, I would multiply by 1,000. So you want to multiply by the largest number needed to get rid of a decimal. Now I'm going to get that 120 moved over so that I have 4x equals 30 plus 3x. I'm going to move the 3x over to the left to get all my variables on one side, and I get x equals 30. I can then check my solution. It does work, and so that is true. Now for conditional equations, contradictions, and identities, here is a table to help you. A conditional equation has one solution set. An identity has many solutions. A contradiction has no solution. Here are some examples. If x equals a number, that means that there is one answer for x. If I get something like 0 equals 0, 2 equals 2, 3 equals 3, that means that there's an infinite number of solutions. If I get something that is false, such as -15 equals -20, there is no solution for that equation. So let's look at what happens as we solve this equation. First, I'm going to use my distributive property. Then I'm going to combine my like terms. Now, notice what happens. I move that 3x over to the left, and I suddenly have no x's left because 3x minus 3x is 0. So I get 8 equals 1. That's a false statement. That means this equation has no solution. Similarly, I have this equation with a bunch of fractions. I want to multiply by the least common denominator, and in this case, I have all 3's, so I'm going to multiply everybody by 3. That is going to leave me with this equation because the 3's are going to cancel out because they each go into themselves one time. Then I'm going to combine my like terms, and this time when I subtract the 3x to get it on the same side, I'm left with 0 equals 0, which is true, which means that there is an infinite number of answers for this. I could plug in 10, I could plug in 20, I could plug in 30, and I would get a correct true statement. In this equation, if I solve and I distribute the 5, it's similar. I'm going to move the x over to get 14x, and then I'm going to subtract 5 from both sides, and I get 14x equals 0. So x equals 0. X equals one number, which tells us that there is one solution in this case. Thank you for learning how to do linear equations. You might need to watch this video more than one time as we did cover several different types of equations and several different steps.